Just like we can convert points between rectangular and polar form, we can also convert equations between rectangular and polar form using the same conversions that we used for points. So the good ones to know are x equals r cosine theta, y equals r sine theta, and r is the square root of x squared plus y squared. We're looking at changing rectangular equations with x and y into their polar counterparts with r and theta. Generally, when we have an equation in polar form, we want it to be r equals something with thetas in it. And just like in the rectangular world, that's not true 100% of the time, but generally that's what we're aiming for, is r equals. So I'm starting off here with x squared plus y squared equals 25. Well, x squared plus y squared, that's r without the square root, so I could call that r squared equals 25. If I take a square root, I don't want r squared, I want r equals, so r equals 5, and it's enough just to have positive 5. There's the polar form of my equation. Maybe you recognize this, hopefully you recognize this. The rectangular form as a circle centered at the origin with radius 5. Here's the equation of a circle in polar form. R equals 5. Nice and simple, gives us a circle around the pole. Here's another one. If I have 2x, well, I'm going to change x into r cosine theta. So that still says 2x, just in a different way, plus 3y, same idea, equals 6. Well, next thing I'm going to notice, I have these two terms and they each have an r in them. So I'm going to go ahead and factor out the r, since our goal is to get r equals. So I got 2 cosine theta plus 3 sine theta. And the 6 is just along for the ride. Well, my goal is r equals, and I have the r factored out here, so let's divide. And I get r equals 6 over 2 cosine theta plus 3 sine theta, and that's the form we wanted. R equals something with thetas in it. There it is. So we're done. The answer to, can I write that 2 times secant theta plus 3 times cosecant theta, is no. The plus sign in between there messes that up for us, so we'd like to, but we can't. In its rectangular form, maybe you recognize this, 2x plus 3y equals 6, as a line. So this is what that same line looks like in its polar form.